Hello, everybody. Today we are going to solve this paper of chemistry, IGCSE Cambridge, paper for theory extended from February March 2025. So we're going to solve this, and obviously, you have to be aware of the chemistry knowledge, the theory part, so that it'll be easy for you to solve these questions. Let's start. The total marks for this paper is 80, and then you have to first write your name here and then go ahead with your center number and candidate number. You just have to write that. Let's starting off with the first question. Using numbers only, state the percentage of oxygen in the air. So the oxygen is 21% in the air. You can also use decimal because they are also numbers. Typical operating temperature in degrees Celsius used in Haber's process. Thing to notice that they asked you in degrees Celsius, so that means you're not supposed to give your answers in Fahrenheit. So that is going to be 450 degrees. You have to know about this from reversible reactions. If you do not know about this, that means you need to study about reversible reactions. Next, number of atoms in a diatomic molecule. The word di only suggests that there are two atoms in a diatomic molecule. So it is two. Next is maximum number of electrons in the second electron shell of an atom. So the first electron shell, which is the K shell, also known as the K shell, has maximum 2 electrons. But the second, which is also known as the L shell, can have a maximum of 8 electrons. 8 electrons. So the answer is going to be 8 electrons. Next is number of hydrogen atoms in an alkane with 7 carbon atoms. So you need to remember the general formula for alkanes to solve this. General formula of alkanes. So the general formula for alkanes are 2 and just a second. The general formula is Cn and H 2n plus 2. Okay. So this is the general formula for alkane. So since there are 7 carbon atoms, you place 7 in place of n. That becomes C7. H 14 plus 2, 16. So it's going to be 16 hydrogen atoms. Okay. Next is the number of particles in 1 mole in its standard form. So that number of particles in any mole, 1 mole of any substance, is called the Avogadro constant. You have to know about this Avogadro number in order to solve this Avogadro constant. And this Avogadro number is the number of particles in 1 mole. Okay? So that is 6.0 2 into 10 to the power 23. Okay. Next question. This question is about ionic compounds. State what is meant by the term ionic bond. So, ionic bonds are the bond that is formed between positive and negative ions. So, bond between cations and anions, cations, cations, and anions. Anions. Electrostatic. So it is an electrostatic bond. Electrostatic. Electrostatic bond formed by transfer of electrons. So you can write about transfer of electrons. We can also look at to the marking scheme if we have any doubts, because this is of 2 marks, so you need to write 2 pointers which are necessary for you to gain those 2 marks, especially when you're writing about the definitions. You should be aware that you have to, in order to get those 2 marks, mention what's there in the mark scheme. So that means you need to mention what's there in your course books and the specification. So, for example, for this question, let us check what the answer is so that we can get those 2 marks. Okay? Yeah. For the first one, we got all the questions, answers, everything's done. And okay. Okay, check it. So the question is, the answer for this is that they should have strong electrostatic attraction between ions, and ions have opposite charges. So, of course, we mentioned bond between cations and anions. This indeed shows that we're talking about opposite charges. And then we mentioned about the electrostatic. Okay, but in order to get proper marks, you need to also mention the electrostatic attractions are strong enough, and transfer of electrons can be mentioned additionally. Next question is potassium sulfide K2S is an ionic compound, and we need to complete the dot and cross diagram of the ions in a potassium sulfide. So we see 1, 2, 3, 4, 5, 6, 7, 8. So we know that there are two, that means there are two potassium, and they both have a +1 charge. Plus 1 charge. Plus 1 charge. +1. Why do they have a charge of +1? It's because they have donated 1 electron to sulfur that had 6 electrons initially, but since the one of the potassium atom has given 1 electron, the other potassium atom has given another electron, it has gained 2 electrons, so it has got the charge of -2, -2. So we know plus charge on each potassium ion and -2 charge on the sulfur ion. Okay. Of course, we need to show, since we need to complete the dot and cross to a diagram of this, and we need to show the charges. Let's see if we've completed them. Yes, we have not completed them thoroughly. How? Because you need to add one more, and then in this you need to add about 7, 2, 3, 4, 5, 6, 7, and then here again 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait, no. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. So One, two, three, four, five, six, seven. So seven. Okay. But since it'll gain one, so we know that. Next question is about the ionic compounds. Okay. Also put for the sulfur. Sulfur, right? One, two, three, four, five, six, seven, eight, nine, 10. Here you'll add 16. So you need to add one, two, three, four, five. Okay, okay. Since they have used cross for this, we are also going to use cross, okay? Because we don't want to like make it like that, okay? So we will also use cross, okay? So you need to draw one, two, three, four, five, six, seven, six only, right? We need only six. Right. So what I'm trying to say is that potassium initially had like it had potassium, so 10. You just need to fill in that 12, 13, 1, 2, 3. Okay. Okay, okay, I get it. Now, what you need to do in this question is simple. Okay. You need to first draw the outer shell and then you're supposed to write the charges. Well, the charges are absolutely correct. You've mentioned the correct charges of plus 1. No need to mention 1. It's not a necessity, but it's good to mention if you can, okay? So potassium sulfide is an ionic compound. You need to complete the dot and crosses structure. So first, you need to know that potassium's number, that is going to be the atomic number. So if you check on the periodic table at the end, you'll find potassium has a atomic number of 19, and sulfur has 16 as its atomic number. So we need to draw 16 and 19 electrons like that, okay? So we are supposed to draw here 1, 2, 3, 4. Here 10 electrons are already drawn. We need to draw 9 more electrons. So here we will draw 8 electrons, and again on the outer shell we are going to draw one more extra electron. Similarly, we will do here also. Here we will draw in this shell 8 electrons, and then in this shell we'll draw one more electron so that it sums up to 19 electrons. Here also 10 are there, but we want more 6 electrons that we're going to put in here. Okay, so similarly you'll just put 1, 2, 3, 4, 5 and 6 electrons, and 2 electrons from potassium. Okay, you'll write that. Similarly here also you will make 8 electrons in this shell and one extra electron in the last shell. 1, 2, 3, 4, 5, 6, 7, 8, and then here one extra, and here same thing you're going to do. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and one extra right here. Okay, next question is ionic compounds form giant ionic lattices. Yes, we know. Now we need to say the name given to any positive ion. Any positive ion is called an cation. Okay, it's called cation. So whichever, if you get confused in this, remember anions are a negative ions. Anions stand for, if it's anions, right? Anion. Anion will stand for a negative ion. Anion is equals to a negative ion. A negative ion. Okay? And cations are positive ions. Cations are positive ions. Cations. Okay? So here the answer is going to be a cation. Cation. Okay? Cation. Fine. Next question is ionic compounds can be decomposed by the passage of an electric current using inert electrodes. State the name of this process. The process when we use electricity to decompose ionic compounds is called electrolysis. 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 Okay. Next question is write the ionic half equation for the reaction which takes place at the anode. So anode is the positive at electrode, okay, whenever we are doing right electrolysis. So here I put anode, here is a cathode. So whenever we are performing electrolysis, anode will have negative ions going towards it, and cathode will have positive ions going towards it. Okay, so it will accumulate positive ions and anode will accumulate negative ions. Okay, so and we are supposed to write a half ionic equation of when at anode, what happens at anode when molten potassium bromide KBr is decomposed. So we have two ions here, K plus and Br minus. So in this case, Br minus is a negative ion and it will go towards the anode. So we need to write about Br minus. Okay. So what will happen to the Br minus here? So Br minus will lose electron, right? So it will basically lose electron, it will give off electron. So how will it give off electron? By electrolyzing. So it will become Br2, which is a bromine gas. It will become Br2, a bromine gas, and it will discharge electrons. It will discharge the electrons into the molten solution. But how many electrons will it discharge? Two electrons, because it has become 2Br. Because, and here also we make 2Br because we need to equate. We need to make the equation balanced. Get it? Now, next question is name the product and state the observations at the negative and positive electrodes when dilute aqueous potassium bromide is decomposed by the passage of electric current. So whenever we talk about dilute, right? Dilute. We need to know whenever a solution is diluted, although bromine is a halogen which has to be discharged before any kind of hydroxide ions, it is important to note down that whenever the solution is diluted, bromine gas is not discharged, rather we have hydroxide ions being discharged because it is a dilute solution. If it's in concentrated solution, then we'll see that bromine gas is being discharged. So talking about products at negative electrode, so what happens at the negative electrode at cathode? So we will find that instead of potassium, because potassium is much more reactive than hydrogen, hydrogen gas will be discharged. Okay, and negative electrode, we need to write the observation. So we will see effervescence, effervescence. Okay, bubbles, anything. Now, products at positive electrode. So, what are the products at positive electrode? So, we will find that there are two products. One is basically oxygen gas being produced, the other is obviously water will be produced, right? And you can also talk about bromine gas being produced, because yeah, although water is produced, bromine gas is also produced. Bromine. Okay, what are the observation? You will see a gas evolving, bubbles, bubbles, and gas evolving. These can be seen. Okay, so these are all the stuff you can see. Okay, so next question is about, you can see the answer key as well. So here we will talk about, yeah. So the answer is hydrogen, and for that we will have bubbles and water and bubbles. So for this you cannot write bromine, right? We have to write hydrogen oxide dioxide. I mean dihydrogen oxide, which is water. Okay. Next, halogens are a group of elements in the periodic table, and chlorine is a member of this group. We need to state the group number of halogens. So they come under seventh group. Okay. And we need to say how many halogens are there in this group. So you can view the periodic table and see we have group 7, and there is 6 halogens. Okay, so 6 halogens are there. Next is suggest the identity of an halogen which has highest density. So density will increase down the group of halogens periodic table. So on the periodic table, when you see, the density will increase down the group, okay, in halogens category. So that means the last one in the halogens group is going to have the highest density. That is going to be tennessine. So just write that. So just write tennessine. Okay, whatever the spelling is. Now the most reactivity is going to decrease than the group. So fluorine is more reactive. Fluorine. Okay. Next is state the name of negative ions formed by halogens. So state the name of the negative ions, anions formed by halogens. So these are called halide ions. Halide ions. Okay. Halide ions. Next is state how many occupied electron shells there are in a bromine atom. So we need to tell how many occupied electron shells are there in a bromine atom. So when we look at bromine, right, we know that bromine here comes in group 7, right? Comes in group 7. So we know that we need to know the group, we need to know about the period of this. So is which period is it in? First, second, third, fourth. So we got to know it in the fourth period. So we know there are four shells that has been occupied by the electrons in the bromine. Next is name the noble gas which has the same configuration as Br minus. Again, let's look at the periodic table for this. So Br minus meaning one less electron than Br. Right, Br minus is one more electron. So we need someone with 81 is 35, right? So one more electron, so 36 electrons. So we have krypton as 36 electrons, so we'll write krypton. Okay, we'll write krypton, krypton, okay. Then we have aqueous chlorine gas react with aqueous potassium iodide. One of the products formed is iodine gas. Complete and balance the ionic equation for the reaction between chlorine and iodine ions. So this iodide ions, and we need to the state symbols are not required. This for 2 marks, so you just need to write and balance it. Okay. So chlorine gas plus iodine minus, which is 2 here, we'll write here 2, right? So when these two react, they form potassium iodide. So chlorine reacts with potassium iodide to form this. So we will have chlorine, assuming that Cl2 is reacting with iodine, is reacting with potassium iodide to form iodine, right? Plus iodine plus potassium chloride minus. So it is this. And here we will write 2 because we have 2. It's a diatomic structure, right? Next is explain why this reaction is defined as a redox reaction. This is redox reaction because chlorine is gaining electrons and iodine is losing electrons. Gain and loss of electrons is occurring. Loss of electrons are occurring. So whenever there is a gain and whenever there is a loss of electrons, we say oxidation and reduction is happening. Oil rig. Oxidation is loss of electron and reduction is gain of electron. Okay. Give color and states of iodine at room temperature and pressure. So the color of iodine is going to be brown, orangish brown to orange brown, you can say. Orange. Okay. State will be, it's going to be solid. Okay. Gray, black, and solid. Okay, it's not brown because remember, iodine has a color of gray, but when iodine is in a solution, it has a color of orange brown. Okay. So in this video, we'll only study this much, and if you want the next video, please comment down for part 2 of the video, and I'll be uploading part 2 in quite a while. You just need to comment upload and I'll be there with the part 2, okay? Thank you for watching.